Hi everyone, I'm so excited to be in ViteConf to talk today about a new way to think about performance. My name is Manu and I work as a framework engineer at Builder.io in the open source team. I've been building APIs and SDKs for the last 12 years, working a lot of open source companies and things from making game engines for iOS to backends and today web frameworks. I work with this amazing team. Mishko, he's the creator of Angular, and also the mind behind Qwik. Adam Bradley, he was the director of engineering in Ionic. I also work with him in this framework. And some random AI hallucination that we got here. And all of us work in this new framework called Qwik. And you might be thinking, why yet another framework? Well, kind of my job today is to convince you that Qwik is fundamentally different, that it solves the performance issue in a completely different way. One of the things is that sites require more and more JavaScript. This is a fact. This graph for web archive shows that in the last 10 years, the amount of JavaScript has been steadily increasing. You might come to me and say that's not a problem for you, and I believe you, but there are many business cases where this is the case. The fastest website usually means in more money. And for example, that 100 milliseconds faster means 1% more conversions. But why is this happening? Why do sites require more and more JavaScript? I'm going to argue that the only reason is because the current developer experience is flawed. We are making frameworks and technology that leads to these bad results because all the developer experience, all the tooling is about how to make things easy, not about to make things easy and performant. Developer experiences achieve more with less, something that is easy to understand, with minimized mistakes, a good documentation, something that you can use for scale or big whole teams. All these frameworks are focused on this. That's why they are becoming more popular and makes developers happy. But what it's not, it's about performance. Performance is something else. Performance today is a trade-off. So I'm going to make it like a diagram here, like putting the things that developers actually want in a website. One is capabilities. You want a lot of functionality, A/B testing, metrics, animations, a lot of things, very complicated site. You also want to have nice DX. You want to have easy to build, micro frontends, low time to market. And in between these two, you can find things like React. React really fulfills this dream. You can have a lot of capabilities and very nice DX. How about if I want performance? 100 out of 100, instant time to interactive, everything. Astro can be in that corner because it has a very nice DX, developers like it, and also is very performant. Maybe between capabilities and performance, we have things like HTMLX, which you can do a lot of complicated things and still have a good performance. But really, there is nothing in the middle, and you can say, well, no, I can make a fast website with React. But then that's you. You will lose the very nice DX. You will have to put a lot of extra energy in React or in other frameworks to make it faster. So it's a trade-off. We used to say that there's two types of companies. Those who prioritize performance at all costs and those with bad performance. This is very fundamental. The principle of least effort is something that you can see over and over in nature. That describes the shape of a thunderstorm. Crystals form these shapes because that's the arrangement of atoms that minimizes the amount of energy. Even people will try to find ways to get to the same place and minimize amount of energy. This is some for example with bats. Even trees have these shapes to minimize the amount of material and at the same time be able to expand and be bigger. So nature is lazy. If you are a React developer, what is your path of less resistance when you are building a website? It's going to be most likely use effect everywhere because it's kind of nice API. You can just do everything. You can just say, okay, I'm just going to put this. I can just get the job done. The problem is that when you do that, you are getting away from this performance. Most of the developers, you will go through that path that make you get the job done faster. But if you really want to hold performance, you have to put this extra effort. You have to go through the top of the mountain. And it happens with everything you think about. I will say that the best developers can write horrible code. But this is not for a lack of understanding. It's just because good developers find the path of less resistance. You need to get from the point A to the point B. This is you. You start from scratch and you need to get to a beautiful functional app. you will go in a straight line, but in reality, you have a lot of constraint. You have resources, you have maybe limited experience in your team, and some boss that is pushing to get a deadline. So the straight line dream is not going to be the case, and you end up with a slow website. I'm bringing this up because performance is not a technology issue. It's a human design issue. And today, a lot of frameworks don't think about it this way. Performance is something that developers have to do. Our dream with Qwik is to completely change that. Qwik allows developers to write complex, instant application at scale without extra effort. The extra effort is the important part here. It doesn't mean that you cannot write a fast website with any framework. What it means is that with Qwik, you get it out of the box. From an authoring perspective, Qwik and React and other frameworks are very similar. It has a very similar component model, and we use JSX, even though we don't use VDOM under the hood. How does it look like when you build a complex website? So in this graph, we plot different frameworks and applications of different complexities from 1, 5, 10, 20, 40, and 80 components. And we see how much JavaScript is being required in the browser. We see that pretty much all of them have the same slope. This means that all the frameworks scale the same way. As the amount of components grow, the amount of JavaScript grows in the same proportion. Today, we are so focused to make the smallest runtime, but we are discussing about things that doesn't really matter for big applications. Qwik is different in its flat. It's the first O1 framework. It's the first framework that has a flat scalability. This is very powerful because you can keep building applications more and more complicated, and you don't have to worry about the size of the application going nuts. To understand the technical aspects that allow Qwik to have this developer experience that embrace performance in it, we have to understand hydration, and we have to understand one of the main bottlenecks that is causing other frameworks to not scale as well. Hydration is pretty much used by any existing framework. There's a root component, and from that root, everything needs to download and everything needs to execute. And at the end of it, the events, those little boxes, are available and the user can interact with it. This means that every time your application starts, everything needs to run, and at the very end, the events and the stuff can be clicked. There are improvements, of course. You can recognize in the previous tree, I'm going to play it again, that there are parts of it that are static components are the ones I put it in black. There's a whole branch in the footer that there is nothing have interactivity. Partial hydration recognizes this and say, look, I don't need to walk the whole tree because there are static parts. I can split my application into islands and be able to do a still hydration of these little bars. So you can actually get interactive faster and running less JavaScript. So it's a big improvement. You can decide a little bit later, I can hydrate a different part of my application, which is again, a very nice win. But fundamentally, it's the same algorithm. I want you to pay attention to these dotted lines. These dotted lines represent work. These islands are not done automatically. This is still an extra effort that developers have to put to make these islands. And I want you to pay attention to this. If you just make an application, you will not have any of this benefit. You still have to put the extra effort to get the benefit, which, as we show with the path of less resistance, it might not be the case because developers just want to get the job done. So it solves the problem from a technical point of view, but maybe not necessarily from a UX point of view. React Server Components is a very similar idea. It's able to identify that a subset of the root nodes are static, and then the application hydrates. The nice thing about React Server Components is still there's a single root. The single root allows things such as communicating between part of the tree without any problems. Also, React Server Components can do some sort of defer hydration. The main difference, in my opinion, is the shape of this dotted line. While in partial hydration, you will split your application into different blocks, into different islands. In React Server Components, you will be more like a split, more horizontal. That means that the root components are static. You don't think about that much into different islands. And as I said, you can have communication very easily. Resumability, on the other hand, is instantly interactive. notice that there is no walking from the root components up to the event handlers. The event handlers are the first things. It's almost like we flip the graph. Now the roots are not components anymore, but the event handlers are always there as the first thing that application gets. That's why it's instantly interactive. You don't have to download all the components, even there's hundreds. And the interesting thing is that there are no dotted lines. There is nothing the developers need to do. You just write an application normally and it will behave this way. It's fundamentally a different algorithm that has these fundamentally different performance capabilities. In theory, there is no difference between theory and practice, but in practice there is. And when I came back to the previous example where you had the partial hydration, and your boss tells you that you need to need a new button in the header to hide and show a newsletter from the form, from the footer. What is that? So now you need to communicate the header with the footer. This means now that, well, less time to refactor. You will have to create a new island in footer, and now you will have to be able to put together the header and footer because you need some sort of communication. Systemic performance issues cannot be solved with a new API. One of the philosophy in Qwik is that we don't want to have a list of best practices. We really spend all our energy into thinking how developers will solve a problem and make sure the framework can do it in a way that is performance out of the box. So a lot of these things is about reducing how much time and how much effort is required to make a slow website, and also increase this resistance towards performance footcamps. If there is something developers should not do, it should not be easy for them to do it. So now that you understand, I can just show you a little bit of how it looked like. Let's check it out.
All right, let's create a new app using npm or pnpm create Qwik. You can specify some folder where we are going to open the app, select one of the main starters, and install dependencies. Let's open VS Code and start playing with it. We can run pnpm start, run the dev server. One of the first things I want you to pay attention is that this application uses a lot of components, a lot of routes. There is a whole meta framework of components and routers, but still this application doesn't deliver any JavaScript. If you don't believe me, we can just go to the routes, we can use components, and there's a bunch of components, there is a bunch of things, and all of them behave like a fully static component. In fact, I can add a button, give it some interactivity. For example, I'm going to do just a very simple alert, hello world. Let's see how this looks like. There we have the button. Still, if I refresh the page, there is no JavaScript, but just in the moment I'm clicking, we will see a little piece of code that gets downloaded and executed. And the alert is here. If we see this code, we see that the only code that get executed was the hello world. This is mind-blowing. Because in Qwik, even if I put a console log at the very beginning of the application, I put logic, this logic is going to happen within the server. But still, if I fully refresh the browser, none of that code ever gets executed in the browser. Still, if I place the alert, that will be the only code that executes. This is only possible because Qwik is able to take a component like this and using our optimizer, break it into a lot of small symbols. So the application here gets broken into one symbol that represents the rendering of the component itself, and also another symbol that represents the on click. This is something that not other framework or bundler can do. Bundlers such as Rollup, which is a technology that Vite uses, can only bundle things together, not break existing modules into lots of small parts. Qwik, however, uses Vite. In fact, the recommended way to use Qwik right now is using a Vite plugin. We are extending the capabilities of Vite and Rollup to be able to break up the modules into smaller ones through their amazing plugin system. The example I showed before is very simple, but we can start to make it a little bit more complicated. For example, I'm going to create some state. We create state with signals. So I'm going to use signal and give it an initial value of 0. I'm going to then render and say, counter, and print the value of the signal right here. Now, in the click handler, instead of printing an alert, I'm going to just say count value ++. So I'm going to increment the value of the signal. Again, for demo purposes, I'm going to put some console logs. I'm going to click here, and I'm going to put at the very beginning, re-render. It's going to simplify a little bit, just to keep it simple. Remember, there's many other components with a lot of interactivity. There is no JavaScript being executed, but just for the demo purpose, I'm going to simplify a little bit more. When I test this application in any framework, we will see re-render in the server because this is being SSR. And we will expect to, when we click here, also see re-render. However, in Qwik, when I click re-render, there is only click. This is mind-blowing if you understand the fact that we are able to execute this piece of code in complete isolation. We don't even need to download this component. In fact, this component is never, ever executed in the browser. The browser never needs to render the button component itself. Resumability achieves this by being able to serialize the state of the application. If we check the DOM, we will see that there is a JSON state, and this JSON state represents the current state of the application when it gets serialized in the server. What we can do with it, for example, if we have the 0 state here of the counter, we see a little 0 here. If I change the initial state to be 10, the initial state will be here. This means that we don't need to re-execute this code in the browser in order for the application to become interactive. The click is immediately there, and it doesn't matter if you have 1 or 1,000 components. In the demo I saw before, when I click, something only gets downloaded when I click. But in production, for example, the website of Qwik itself is using, Qwik. We use a technology called speculative module prefetching. When we open a Qwik application for production mode, we open the DevTools, we will see that the service worker that we specify here is pre-downloading everything that is possibly interactive. It doesn't mean that it's going to download everything. It's just downloading the things that are possibly happening in this page. For example, when I click to change the dark mode to light mode, it will show here that the cache was actually already here. This means that we don't infer into any latency costs. It's almost like an application streaming. When you see a video on YouTube, the browser is already prefetching the next frames. So even if you don't download the whole video upfront, you can still enjoy it. The same principle is used for Qwik when we are able to stream and prefetch modules before they are actually needed. What this means as a developer is that you never have to do any sort of dynamic imports. You don't have to worry about how to bundle code. You don't have to worry about how to optimize your code to have fast re-renders. Qwik is handling all these things for you. There is no best practices. And I think that's the mind-blowing fact about Qwik. That's what gets people very excited, that there is nothing to learn to make an application faster. Whatever you write in Qwik automatically will download no JavaScript. In fact, in Qwik, you have to force the early execution of JavaScript. If I want some code to execute as soon as possible, I have to specify with something called use visible task. So for example, if I say, hello, and I open this in the browser, I will see the hello. That's the only way in Qwik to execute code upfront. Otherwise, it doesn't happen. This may be interesting for things like running some WebGL application. The ability for Qwik to do this kind of breaking out modules into different parts can be used for things such as executing code in a completely different environment. For example, just by using the server $, I'm importing for our meta framework called Qwik City. Now, the same component that used to print click, now it doesn't do anything here because in fact, the click happened in the server. Again, imagine just being able to change that makes it able to say click, 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 nothing here, or say server $, and then click, 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 click in the server side. It's just a very small thing of what Qwik can do. We have a full meta framework that allows to do directive-based routing, middlewares, endpoints, integrations with all sorts of deployments, and everything you build, even if it's extremely interactive, it will execute no JavaScript out of the box.
Thank you very much for your attention. And please follow me in Twitter, Manu Corporate. I also make cool videos and explain concepts about HTML and CSS. And please stay for the next ViteConf speaker. See you.